This is the second PowerPoint for the P8 module. In your book, page 3, section 2, we'll take a look at MIG welding aluminum. Page 3, aluminum produces an oxide film that resists corrosion and heat. The highly fluid weld puddle is from aluminum's low melting temperature. Direct current electrode positive is always used to weld aluminum because this electron flow provides a cleaning action in the material. That's called cathodic cleaning. Backhand welding is prone to shielding gas loss. This is why the pushing, also known as forehand technique, is preferred. Stringers compared to weaving will give better puddle control. Page 3 and 4, table 1 in your book shows gas metal arc welding behavior with the two power sources. Constant current power utilizes the voltage sensing wire feeder, also known as a suitcase welder. A constant voltage power source is more common, with the wire fed constantly. Arc length is affected as you increase and decrease voltage, and current is related to the wire feed speed. Page 4 and 5. Aluminum electrode wires are quite soft and tend to buckle easily under pressure. The push-pull wire feeder can get you up to 30 feet away from the machine. A spool gun is more common and less troublesome because the wire only has to be fed a few inches from the spool. On a spool gun, wire feed speed is found at the bottom of the handle. A nylon liner reduces friction and is used for softer wires. And U-groove drive rolls feed soft wires smoother than the knurled or V-groove rolls. Table 2 on page 6 shows filler wires for aluminum alloys. Aluminum is classified by composition to match base metal properties as closely as possible. Just like the alloy, these filler wires should be as clean as possible, sealed packages stored at room temperature. And because aluminum has one of the lowest melting temperatures, the weld puddle is much more fluid compared to steel and its alloys. Most common filler alloys is 4043 and 5356. 4043 has 5% silicon added, which makes it softer and easier to feed. If surface temperatures are high, 4043 is your best choice and is less crack sensitive. 5356 has 5% magnesium added, which increases the strength, but will not stand up to high temperatures. 4043 has a better bead appearance than the magnesium series, but 5356 is widely used as a general purpose alloy. And a curveball for your test, 4804, I see on the screen there, is not a filler wire. Page 7, shielding gases for welding aluminum must be inert, meaning they do not interfere with the weld puddle. They just create heat and shield out atmosphere. Unlike CO2, which is reactive and reacts with the weld pool and allows a small amount of atmosphere into the weld zone. We'll talk about CO2 and its behaviors more in the P9 module. Argon is preferred for materials up to 1/2 inch. It's easy to control and improves the cathodic cleaning action in reverse polarity. Pure helium is not recommended because it just gets too hot. You can mix helium and argon to increase the current density, which makes welding materials over 1/2 inch much easier. Metal transfer, page 7. Spray or pulse spray metal transfer is the best choice for MIG welding aluminum. Pulse current is a high peak current and a low current that continuously change back and forth. And with that, there's a background current that keeps metal flowing. As mentioned earlier, pushing provides best shielding gas coverage of the arc. Page 8, joint preparation. Shearing, plasma cutting, or a grinder is performed. Aluminum must be pre-cleaned before welding because of that oxide film. This can be done mechanically with a wire brush or a wire wheel that's only used for aluminum. Chemicals can be used but must be rinsed with distilled water. Distilled water is water that has been boiled into vapor and condensed back into a liquid in a separate container. Rinsing with regular water would leave impurities like mineral deposits on the material. On page 9, aluminum has much lower melting temperature than most metals and their alloys. This is why hot shortness is the main problem. Hot shortness is losing tensile strength in the material near the melting temperature, resulting in cracking. Welding faster reduces heat input, which can help reduce hot shortness. And crater cracks are also common. The puddle freezes very fast, so if you do not have enough filler material at the end of a weld shrinkage pulls the end of the weld apart, leaving a crater. You can pause at the end of a weld and then stop, or you can incorporate runoff tabs to finish the weld off. Last two slides are summaries. Pause if you need to, get this stuff down. Just a reminder, potential and voltage have the same meaning in regards to power. Test is 35 questions, and it will be heavy on aluminum.